Can stem cells reverse aging? Well, I certainly hope so. A lot of work is ongoing right now looking at some of the different reasons why we age. Hi, I'm Dr. Bob Hariri from Piloting Health, and today this is going to be kind of a fun opportunity for me to answer some of the most sought after questions on the internet about stem cells, regenerative medicine, cellular therapy. And I hope you understand that because my entire world revolves around the placenta, a lot of this will be focused on the technology we're developing here. The first question out there is, do stem cells grow back? Well, here's the reality. Stem cells, which every single stem cell in the body originated from that first, what's called a totipotent stem cell that's created when the egg is fertilized by sperm. And that gives rise to the development of the embryo. And the embryo gives rise to the development of the placenta and the fetus. And all of these things contain within them a whole population of stem cells which go on to mature and specialize into all the different cell types of the body. There is, in fact, a process called renewal, where during each cell division, the stem cell actually makes a copy of itself along with a copy that goes through the process of differentiation. Now, we call this cell division process, it's either asymmetric or symmetric. In some cases, the stem cell population simply wants to make more versions of itself, and that's a symmetric cell division, where it makes two perfect copies of two stem cells. In other cases, it'll make a copy of itself, a stem cell, and it'll give rise to another cell, which actually goes through a process of differentiation and starts to mature and specialize. And so the question of do they renew themselves and make more of themselves? Absolutely. They do copy themselves and make more of themselves throughout our lifetime. How do you collect placental stem cells? Well, here's the bottom line. The natural process of childbirth yields one newborn baby and the leftovers of the placenta, which are discarded. These are basically a biological waste material. Whether it's a vaginal delivery or a cesarean section, the byproduct of a healthy full-term pregnancy is a healthy baby and the leftovers. The leftover placenta is collected by the doctor at the time of birth, and it is packaged and then delivered and shipped to our laboratories at Cellularity, and we process this organ to derive the cells and the biological materials that can be used to treat patients. Are stem cells specialized? There's different kinds of stem cells, and let me explain that. At the moment of fertilization, you create what's called a totipotent stem cell. Totipotent means that it can go on to create an entire living, breathing organism. In the case of a human being, a newborn baby. Stem cells also can be specialized. They can be developed partially. They can be developed into what are called hematopoietic stem cells. Those are stem cells that give rise to the blood and immune system. Those are the kinds of cells that are found in bone marrow or found left over in umbilical cord blood. They can also be stem cells which are kind of pre-programmed to drive down one part of what we call the tissue lineages. Our body is made up of many different mature cell types specialized in different tissue lineages. Those lineages are called endoderm, ectoderm, and mesoderm. For example, mesodermal tissue goes on to create things like bone and cartilage and muscle. The fact is that stem cells are specialized to some extent. The very nature of a stem cell means that it has a degree of versatility in how it can mature and specialize. But the fact is that there are different categories and different types of stem cells that have a certain degree of specialization. Do stem cells have DNA? Absolutely. All cells, except for red blood cells, after they get rid of their nucleus, all cells that have a nucleus have DNA. So think about DNA as your biological software. It's the coding language, and this was taught to me by the first scientist to ever read the human genome, decode the human genome, Craig Venter, one of my heroes and a dear friend. Craig showed that DNA can be thought of no different than the kind of coding language that's used to run your computer. And this DNA is a molecular chain, a sequence of molecules that form a very specific pattern that encodes a language that tells your cell what to synthesize. And so the answer is every cell has DNA. Why are stem cells banned in the US? Well, here's the reality. Stem cells are not banned in the US. There was a period of time when there was quite a bit of controversy around where you could legitimately find and use stem cells for medical purposes. And if you go back 25, 30 years when some of the early discoveries were made that you could get stem cells from discarded embryos, there was a concern that the production of embryos might incentivize people to do things in a sort of nefarious way and to produce embryos that were going to be destroyed just for the purpose of harvesting stem cells. Well, fortunately, because of our discovery that you don't need to do that, that you can actually wait until a pregnancy is completed and collect the placenta, which is a waste material, and that organ contained all the necessary stem cells to turn into therapeutics, meant that it wasn't objected to by any faith organization. There was really essentially no controversy about it. In fact, there's really no objection to the use of the leftovers of a full-term pregnancy, and these cells can serve all of the purposes envisioned for cellular and regenerative medicine. Do stem cells help with hair loss? Well, I certainly hope so. Like most men my age, my hair is a lot thinner than it used to be. And the fact is that we're now learning that stem cells, particularly those in the hair follicles, are responsible for continually renewing hair growth. And so there's a lot of work ongoing today in not only cells themselves, but even byproducts of stem cells that may in fact improve the health of the hair follicle, restore its quality and its thickness. And I do believe that we are on the verge of breakthroughs where stem cells and stem cell therapy in general, combined with all the byproducts of the cells, will be a tool to not only restore hair, but to prevent hair from being lost. Do stem cells cause cancer? Well, early on, there was a concern that a stem cell, which had this ability to mass produce itself, to differentiate and divide and divide and divide, might do something aberrant and cause a cancer. Well, the fact is, we do understand that cancer is the product of an abnormal cell which goes on to divide in kind of an unrestricted manner and create these abnormal tissues that constitute what is a tumor. The fact is that stem cells as a therapeutic product from the kinds of sources we use today, like from newborns material, either from cord blood or from placenta, and stem cells derived from normal bone marrow, have not been shown to cause any type of cancer. And fortunately, the Food and Drug Administration of the United States, which has done a spectacular job in holding the science of this field to demonstrating that tumor genicity, the propensity to create tumors, was not a risk for the cell therapy products that are currently in clinical development and under investigation, do not cause, to our knowledge, any increased risk of developing cancer. Can stem cells increase in size? Well, the reality is that stem cells, like most cells of the body, kind of fall within a range of cell sizes that don't differ too much, but cells do come in different shapes and sizes based upon the level of specialization. But stem cells in general do not vary in size all that much. How many stem cells exist in a placenta? Well, you know what? The placenta, to our knowledge, is basically nature's stem cell factory. And in our hands at Cellularity, we have found that we can isolate hundreds of millions to billions of stem type cells. Some of these stem cells are what we call pluripotent. They're highly versatile. And some of these stem cells are somewhat specialized, such as hematopoietic or blood forming stem cells. But the bottom line is, to date, the number of cells you can recover from an average placenta is so much greater than any other source that it's an ideal place to start when you want to develop a large, scalable therapeutic. Do stem cell supplements really work? Well, there's different categories of stem cell supplements. There are some things that are considered to be derivatives of stem cells that are used as supplements. Some of these are factors, they're nutrient factors, they're minerals, they're sort of like vitamins that you get in the health food store and so on. Depending upon the type of supplement that we're talking about, some may in fact be helpful in promoting the general health and viability of of all your cells, including your stem cells, and some may have very specific benefits. It all depends upon the type of supplement and what the underlying biologic rationale for using it is. Can stem cells help heal wounds? Well, the fact is that when you have any type of an injury or wound, at the margins of that wound, your own endogenous, your own natural occurring stem cells actually go through the process of responding to the injury, dividing, and making up the filler, if you will, for the gap or the void that's created by the wound. And so stem cells are a very important part of wound healing. Anything that helps maintain the health and promotes the growth and development of your stem cells is going to benefit you when you want to heal. Can stem cells reverse aging? Well, I certainly hope so. A lot of work is ongoing right now looking at some of the different reasons why we age. And one of the hallmarks of aging that's well accepted amongst the most highly regarded scientists and clinicians in our community is that stem cell exhaustion does occur with age. And it sort of makes sense, right? If stem cells are responsible for continually renovating and renewing us during our lifetime, for example, in our bone marrow, you make 1 trillion new blood cells every day. They're coming from the stem cells that reside in your bone marrow. Over time, for lots of reasons, you can wear those out and you can exhaust the number of stem cells in different parts of your body. And so it's conceivable that anything you can do to restore, replace, or augment those stem cells might in fact benefit you during aging and either replace or supplement your own natural system that keeps you young. I can tell you that we're very interested in finding ways to use cell therapy to address the degenerative processes that you see in aging. And we are very, very excited about the prospect that some of the derivatives of stem cells, even the immune cells that can be produced, may in fact help us impact and delay some of the changes that occur that are inevitable with aging. Can stem cells help repair sports injuries? Well, as we've often talked about, stem cells are critical to the process of renovating and renewing your tissues and your organs in response to injury, disease, or just aging. The fact is that when you have a sports injury, for example, a muscle tear or a ligament tear or a tendon injury, your body's own reserve of stem cells participate in the repair process. It's very conceivable, and there's a lot of work ongoing today looking at ways to augment that natural effect by giving stem cell or stem cell type derivatives into that injury zone in order to support the healing process. I'm very optimistic that in the very near future, you're going to see an ever increasing body of data and literature which is going to support the use of cellular and regenerative therapy to help accelerate the process of recovery after injuries, particularly in sports injuries. Do stem cells help in fertility? Well, that's a really good question. The bottom line is fertility is based fundamentally on the biology of stem cells, right? The newly fertilized egg, when you put an egg and a sperm together, you create a stem cell. You create what's called a totipotent stem cell. In some cases where fertility is compromised for a whole variety of reasons, the health of the eggs, the health of the sperm, it's very plausible that stem cells may in fact help boost the behavior and function of those natural germ cells that are necessary to create the egg, the fertilized egg, which becomes the embryo and ultimately the fetus and newborn. The truth of the matter is that many of the factors that are released by stem cells are critically important to the growth, proliferation, and differentiation of cells from an embryo. So it's very, very likely that the field of fertility will be enhanced by the use of regenerative and cellular therapies in the future. How many stem cells are in the body and how many stem cells are actually needed for an effective treatment? That's a great question. Well, as an average size adult, we are maybe 25 to 30 trillion cells in our body. And those cells are continually going through a process of renovation and renewal. So in your lifetime, you're making hundreds, thousands of trillions of cells during your lifetime. And all these cells originate from primordial stem cell that's created after fertilization, when the egg and sperm come together and create that first cell. Imagine the replication and proliferation fidelity that stem cells have to be able to continually through your lifetime, maybe 80, 90, 100 years, be able to make perfect copies of themselves that can go through the process of differentiation and specialization to become the complicated cells and tissues that make up our organs. The fact is that we know that stem cells have this intrinsic replicative ability, the ability to mass produce themselves, and that's critical. In the concept of using these cells as therapeutics, the dosing of them is still under considerable investigation. But if you look at one area where we have a lot of experience, which is stem cell transplantation for fixing your bone marrow, usually in conjunction with treating cancer, the number of cells that you have to give to a patient to restore that function or replace the function of the bone marrow is in the tens to hundreds of millions of cells. Now that sounds like a lot of cells, but 100 million cells in 25 trillion is a relatively small number. I might add one other thing. As we're thinking about how stem cells may benefit us while we age, or as a way to slow or delay or even reverse the aging process, one of the things we're working on is to better understand the calculus of stem cell administration in that particular indication. What I mean by that is, if you're a 70-year-old individual, the cells in your body biologically are 70 years old. If I introduce into a 70-year-old a percentage of cells that are coming from, for example, a newborn donor, that biological age is zero. Imagine what the average age in the body would be if those cells distributed throughout your entire body. And that's a complicated question because as the new cells are introduced and they divide and take up residence in your body and contribute to your overall biological age, over time, the more young cells introduced to the population of older cells should change the average age in your organs and tissues. And this is a concept that we're working on to better understand, but I do believe we're going to come to a point where we recognize that you can change the average age of cells in your body by introducing young cells into an older recipient. And by the way, for all the families that chose to bank their children's stem cells at birth from umbilical cord, blood, or placenta, if you think about it, those cells, when they are processed and put into cryopreservation, are put into a state of suspended animation. And I believe that in the future, we're going to be able to augment and supplement a person's very own cells by giving them back newborn copies of their own cells, which means that they're perfectly matched to them and they could contribute to lowering the average age of cells in their body. Where can you get stem cells if you want to use them to address age-related conditions? Well, that's a really interesting question. Now, a lot of us in the field are working to make available to everybody what's called an off-the-shelf cell therapy product that has the benefits of newborn cells, but could be administered to an adult. But keep in mind that your cells today are always going to be slightly better than your cells tomorrow, and clearly they should be a lot better than your cells 10 years from now. And so just like for the last 40 years, expectant families have been given the option of banking the leftover cells from their baby that are found in the cord, blood, or placenta and storing them away for their child. Adults are also going to have that opportunity to store cells that can be collected now for potential use in the future. And there's many potential great uses, well even beyond applying this to treating age-related conditions, because they serve as a platform to produce many of the cell therapy products that may be used in immunotherapy for treating a number of diseases, cancer, infectious diseases, and so on. So the field is moving very, very quickly, and the bottom line is that if you have the opportunity to store your cells today, you can be assured that they're going to be healthier and better than the cells that you could store 10 years from now. So once again, thanks for joining us. I'm Dr. Bob Hariri from Piloting Health, and I'm looking forward to seeing you on our next episode.